All right, so we're going to be working with this Spark code, which is linked to under this video. You can go and check out the GitHub version of this script and try it out yourself if you've downloaded the AlphaVantage data using the Unix tutorial that we did earlier. So I'm going to close this window and work on just typing these lines in, and we're going to talk through the script as we go. Okay. So here we are on the Unix shell. The first thing that we need to do is open the Spark shell. So to do that, we're going to type the command spark-shell. This is, of course, assuming that you have Spark properly installed and accessible to you. So we're going to run that. And it's a pretty noisy start. There's a couple of configuration things with Hadoop that are not set on this instance that we could set, but we don't need to right now. And then it does this cool ASCII art that says Spark and then version 2.3.0. And of importance here in the messages, we also see a line that says using Scala version 2.11. So that's telling us that the language we're actually speaking here is Scala. It's just flavored with Sparkisms. So it's a bit of an oddity. There is, if you're into it, there's a PySpark shell as well. So an interactive Python flavored Spark that you can use if Python is more up your alley. So we're going to use the Scala version for now because there are a lot of good examples out there on the web that use this format. All right, so I'm going to Control L, clear the screen, but now we can see the command prompt begins with Scala caret, and that's going to tell us that we're working inside of the Spark shell. All right, so the first thing that we need to do are a few imports. All right, I'm going to paste the next three in. All right, so a couple of Apache Spark configuration, Spark context, Spark conf, and then we're loading in SQL functions and Spark SQL, which are both going to help us handle the data files that we're going to be working with here. So next thing that we're going to do is we're going to read the data. So in Scala Spark and the Spark shell, to define a new data object, most of the time we're going to declare a val. So that's the type. So val sc, what I'm going to call this is Spark cluster NYSE, because we're reading data from the New York Stock Exchange that we downloaded earlier. And the function here is spark.read.format. If you're familiar with Python, these dot notations in these functions are very Pythonic in their structure. So we're going to read, the format is CSV because that's what we downloaded before. There are native JSON readers here in the Spark shell as well, but we are working with CSV. Option, we do have a header in these files. So header is true. And then .load, and now we're going to pass in what we actually want to load into this session. So we're going to say load AV data /*. And so you might recall that the asterisk is a wildcard character. It means match anything in the shell language. It also means that here. So what we're saying is load anything that's in the AV data folder into this one object, scnyse. So this depends on a couple of things. This requires all of the files that are in that AV data folder to be in the same form. So the same columns with the same kinds of data in each one. And it's a pretty robust reader. It will keep going if it encounters a change in type. It'll change numeric to characters and stuff like that. But here we have all these files that are in AV data should have come directly from the AlphaVantage API in the same exact format. So we should be good to go here. So I'm going to run that. And while it's running, the Spark shell gives us a little bit of a progress bar showing us what it's done. It first maps the files and then it reads the files. Really reading kind of the metadata of these files because it's doing this in a very efficient way. And it gives us a warning that we can pretty safely ignore. It says failed to get global database global temp returning no such object. That's a configuration thing. We can hook Spark up to a database engine that makes data access a little bit better, but it doesn't particularly matter. We can use these CSV files in the same kind of way. So that's not something that's failed. That read has actually worked fine. And we can check it by checking, we can do the name of that object, and then we can apply a function like count to check the number of rows that we've read in with this read. So again, it's going to give us a progress bar and shows us that we have about 10 million rows in the data set that we've loaded. So I don't know if you noticed along the way in that progress bar, they went a little bit quick. In the reading progress bar, it showed that there were about 3,100 files that were read, each one with daily records going back 20 years or so, and the total that we got, which we could check that math later, is about 10 million rows. So that's pretty cool. We've read, 3,000 files, and to get 10 million rows in an interactive session here, which is impressive. This is where Spark really shines. Because it has a lot of shortcuts and mapping that it does with the data. It gives us access without overloading our system or taking too long. So I like that. We could also take a peek at this data. So scnyse.show. I think this will work. There we go. All right, so that gives us a sneak peek. This is, it says only showing the top 20 rows, but that's fine because it gives us confidence that we have read these in the right ways. Timestamp, open value, high for the day, low for the day, and the closing value. The adjusted close, which we got because we used the time series adjusted. Query function on the API, the volume, dividend amount, and split coefficient that we can use to track value over time in these stocks. But you might be wondering right now, since we read from 3,100 different files, and those should have been all of the stocks on the exchange, how do we tell where these data came from? So that's kind of an oddity. Technically, those data aren't in each of the files. That information is stored in the file name itself. And so in order to get that, we're going to have to do a little bit of manipulation of these data. Technically, those file names are in the metadata of this scnyse object. So we're going to call a new object. I'm going to call it val_df. So for data frame, we're dealing with these tabular data structures called data frames here. So I went for a more generic name down here for easier typing. All right, so scnyse with column. So we're going to add a column to this, to the scnyse data frame, and we're going to call it path. And we're going to use the function input file name. And that's going to grab the file name that went along with each row and append it as a new column in this whole table. Okay, and that gave us nothing, but we can check df.show. Let's just try that, df.show, and it prints it out. It cuts off this last bit here, but now we can see that we have a path variable. They all look the same. If we want to see all of that, we have to say in parentheses false. So I suppose that's don't cut off our data, even if it's too big to put on one row. All right, so now we've got all of the full paths, starting with the symbol IP. So that's kind of cool, but if we wanted to actually, I don't know, filter on the symbol, we might not want the full path. So let's see if we can split that path up, which we can do. For this one, I'm going to copy this and then explain this line of code. All right, so we're going to create a new val, df2. We're going to say df with column again. We're adding another column that I'm going to call split path, which is going to be the output of a function called split. Split is going to split the value of the path column on a slash, and it's going to return that as an array. And then we're going to drop the path variable. So we're replacing path with an array of the path values, each folder in the list there. And then we should be able to pull out the value that we actually want from there. So let's do df2 show false. All right, so it just changed the formatting here. Now we have bracket, file, project NB2 on down the line. And the last token in this array is IP. So that's 1, 2, 3, 4, 5, 6. 6 elements into the array. Scala is a 0 index language, so that's actually the 5th index value in the array. Something that looks like this. So this one, it's a similar kind of operation. We're creating a new data frame. This time on df2, we're selecting particular columns here. So we're selecting split path 5, which is our the 5th index in those path arrays. So the actual symbol that we want here, and then all of the columns that we also want to collect here. So all the regular ones, timestamp, open, high, low, and all that. And so when we run that and we do df now 3.show false, now we've got the first column is our symbol, and then timestamp and all the valuation columns that go along with that. So we've pulled out of the metadata from the read all of the symbol values, hopefully, and and put them into the rows where they belong, so that we can go and use that for downstream analyses. So now, if we if we go through and manipulate any of the other data, take a time slice, filter for particular values, we'll be able to see which stocks go with the raw data over here. Okay, so that's thing one. We read the data in, and we have manipulated a little bit, cleaned it up so that we can see where it came from. So now I want to try to demonstrate some filtering. Right, so we're going to do a val filter 1. We've got 2. We can try all kinds of examples, but we'll try one of these first. And we're going to run df3. So that's our data that we're putting in is df3.filter. That's the function we're applying to df3. And we're going to filter on the column open. So what are those opening values? And we're going to look for rows that have an opening value of less than or equal to 10. And if we've done everything right, that runs. And now filter 1.show should have some different data in it. There we go. So we see different symbols here and different dates when we had stocks that had an opening value of less than 10. So we've got a bunch here that are less than a couple of dollars, and we could look at those, right? So we could filter in a variety of ways. We might look for, the highest percentage values, lowest percentage values, particular slice for a particular reason. All right, so that was filter column open less than 10. Let's see, we could do, well, yeah, that's fine. All right, and then we looked at that. And then just to show where we've gotten to, we're going to do filter one count. And that should go pretty quickly. And it shows we've got 160,000 rows. So just as a comparison, when I got that up here, DF3 count is going to be substantially larger than that. So we went from 10 million rows in the raw data to 160,000 rows in the filtered data. And that was, this is the power of Scala. It was all interactive, very fast. Filtering and all of these other functions have been very powerful for us. So 10 million rows, that's not crazy, but it's responsive, interactive, and giving us quick results. All right, another one, val filter 2, and we're going to do the same thing, df3.filter, and we're going to do a different comparison. We're going to look for days when stocks gained value. So we're going to look for where call close is greater than call open. Let's see what that gets us. All right, see the filter's super fast. All right, and then we're going to do filter2.show. And we get a different set. This is probably substantially larger, on average, maybe about half of the days of it, if all things are random, about half the days the stock should gain value and about half the days should lose values. Let's see if that seems about right with a count. Filter2.count. And let's see what we get. Yeah, so, 4.9 million records out of about 10 million records, the stocks involved gain value over the course of a single day. Seems about right. All right, cool. So we've done 2 of our 3 goals now. We loaded some data in and manipulated it, cleaned it up a little bit. Now we've also filtered that data. And our 3rd goal for the day is to write the filtered data out to a file. So let's try that out. So I'm going to do, we're going to save filter 1, the output of filter 1, because I think that's kind of interesting. What are these penny stocks that are out there and when were they? And what maybe we want to look later as to what happened to them after they had these very low values. All right, so we're going to do filter 1 dot coalesce 1. So what that's going to do is it's going to take, technically filter 1 is still potentially many different representations of files, or a bunch of files in a single representation in the Scala language. We're going to coalesce that into one single object so that when it writes to a file, it writes to a single file. And then we're going to use the function write and .csv, so it writes a CSV file, and we're going to call that CSV file Spark NYSE filter. We're going to run that, and it takes a bit of time because it's actually got to write the data now, but it's going to save the output for us to use in a downstream analysis. Okay, there's not much more to see after this. We will filter and explore and practice this more in future sessions. So that's it for now.